Hi everyone, today we are going to work on the problem number 1 from LeetCode, which is do sum. Let's look into the problem. Alright, in this question we will get a list, and that list will contain bunch of numbers, and we will also get the target. Based on the question, we have to find out those two numbers in the list which can sum up to the target. So with this example, the number has almost 4 integer in the list, and if we add 2 and 7, then that becomes equal to the target. In order to solve this, I'm going to write the Python code in Sublime editor. Okay, so here we go. We'll create a new file and we can save this as a tosum.py. Okay, so let's get the variables from here and we can use them straight away in the code. So before we write the code, the approach to solve this problem is the first approach which we are taking is a brute force approach. What that will do is we will iterate through the number, and once we pick up the first position number, we'll try to add that number with the rest of the position number and see which one comes equal to the 9. So we can do this by using to loop on this number variable. Okay, so the way it will work is let me demonstrate that in a Excel. So we have this number, and our target is 9. So we are going to use nested loop in this brute force approach, and we will run the loop on two variables. So the first variable is going to be I, and then the second variable is going for j, and j will also run across the same set of elements. So what will happen is in the loop, I is the topmost loop and j is the second nested loop. So once I is here at 2, then we'll add this position of I to the 7 to 11 and to 15, and then we will check like which one is coming equal to the target. So that way for I equal to 2, my inner loop will run for rest of the element. So suppose and this is like the first iteration for the outer loop, and once we suppose like if we don't find in the first iteration, then the I will move here, and then our j will run from here to here. So 7 plus 11 or 7 plus 15. So that's how it's going to iterate over the two nested loops. Okay, so I'm going to call this as a def brute force function, and this two input to this function, nums and target. And this is my print function, which is calling this user defined function nums and just send the list and the target value. Okay, so in this function we can start with creating one variable which will contain our result. We can keep that empty for now, and then we will write the outer loop for I in range 0 to len of nums. Alright, and then the inner loop will run from I plus 1 from the next position. If I is at 0, then j will run from 1. If I is at 1, then j will run from 2. So it's always plus 1, j plus 1, I plus 1, and then len of nums. So before we look for the the other number, we first have to do the minus, and after doing the minus we can check for that the other number in the remaining inner loop. So I can call this variable leftover equal to target minus nums equal to nums of I. So this way we are determining that what number we have to look in the inner loop. So once we have the leftover there, then we will check if the leftover equal to nums of j, then that's our result. And what we will do is we will save that result into here. So my result will be I. So we know like which position I is at, and then we can also take j. Yeah, and whenever we find the first combination which is equal to target, I think that's what we need. All right, let's return the result and see if it is working or not. Also, we can put the break in here. So if we find our result, there's no need of running through rest of the loop. All right, let's run this. Okay, so this is failing right now. All right, so we have to remove this. Nice. So this is running for this example, and if we change this to 26, this should give us 2 and 3. Yes. So I think this answer is working, and as we know that we have the nested loop here, so the time complexity would be n square, n into n. But there's a easier way to solve this just in time complexity of n, and in that solution we have to iterate through the loop only once, but we have to use the hash map. And since we are going to use the hash map, it's going to use the memory space, and then that memory space would be equal to n. Let's try to go through the example in the Excel, and then we can write down the code. So using hash map, what we have to do is we are only going to iterate through the loop once, and as we are going through the loop, we have to check if the remainder is there in hash map or not. If it is there, then we find our two elements. The first element is like what we have from the loop, and the second element would be from the dictionary or hash map. So for example, but before we get our second element from the hash map, we have to first build the hash map. So while we are going through the loop, what we can do is we can create our hash map here, and hash map will have key value pair. So this is my key and this is value. So once we are at this position, we will store the key 2, and the value is the position. All right, so this is when we are at position 0, and let's try to run through the example. So I is at 0th position, and once we are at this position, we will check if the remainder of first like once we iterate through the loop, we have to take the leftover, and leftover would be my target minus num of I. So once we have our leftover, we have to look for this leftover in our hash map, right? So initially there's nothing in the hash map because it starts from blank. So yeah, for the first time this condition is not going to be correct. So if nothing is there in the hash map, then we are going to insert our first element in the hash map. So we will put 2 here and then 0. Then once we are at the second element, which is this, and our target is 9, right? So once we are here at the second position, again we will calculate the leftover. So it will be 9 minus 7, which is what? Which is equal to 2. So once we have our leftover, we are going to look for this key 2 in the hash map, and we find it there. This element is there, and once we find the element, we will take the value and we'll also take the I position, and that would be our result. Okay, so let's write this in the Python. I'm going to call this function as optimal, and we are going to use the same set of arguments. So I'll have this empty list which will have our result, and then we'll also declare one hash map that will contain our elements once we go through the list, and then we will start our iteration for I in range 0 to len of nums then we will take the leftover, and that we will do by target minus nums of I. Okay, so once we have the leftover, we will check if leftover in hash map, then our result would be the hash map of that leftover comma I. So, and we will keep this under list, else we will insert into the hash map. And how we will insert? We will insert as nums I, and then that will be equal to, we are storing the information in the value, not the information, we are storing the position in the value. So, and that would be equal to I. So if we don't find it, if we don't find the leftover in the hash map, we will insert that into the hash map, and that's it. And if we find our example, we can break out of the loop. We don't have to iterate through the entire list. Okay, let's try to run this. Okay, we are not returning anything, maybe that's why. So return result. Okay, so we are getting the correct answer in both the scenario, and the time complexity for this solution is on, because we are only going to iterate once through the entire list in the worst situation. And space complexity is also going to be n, because at worst we'll be inserting every element in the hash map. That's it. I think we're good with the solution. Thanks everyone.